So now we're rebooting our system. We'd like to perform another custom installation. This time we will use 2 disks. We've provisioned an additional 8 gig storage block. So let's boot the default installer. This way we'll be able to spread our important mount points across multiple disks. And that'll relieve some of the storage concerns as we saw earlier with 107% usage of /user. So there could have been some mapping there across the root file system to account for the extra space consumed by the ports. So let's go ahead with our selections here. As mentioned, we have standard, express, and custom as the 3 modes of installing FreeBSD. Just to recap, standard and express are very similar. They both present a series of steps that are to be followed logically. So for example, initially we start off by laying out the partitions or allocating the slices, laying out the partitions, installing or not installing the boot manager, selecting or not selecting a distribution such as all ports, and then proceeding with the commitment of the changes in the installation of FreeBSD. That's a logical series of steps to progress through in installing the operating system. However, the difference between standard and express is that standard will display for each step in the series a series of overheads or logical prompts that accompany each of the steps that are to follow. So that way it alerts you each step of the way what is to take place or what is to follow, and that makes it rather useful. So that is the difference between standard and express. Standard basically presents us with the overheads, express does not, which is why express is a quicker means of installing FreeBSD. Custom, however, does not present us or walk us through that logical series of steps. So it expects us to navigate as experts through those steps as we see fit. We ultimately end up navigating through the steps anyway, because it's the logical way to set up the system. Another difference between custom, standard, and express is that custom allows us to navigate to any portion of the installation at any time, save of course the commit stage where the file systems are allocated and files are copied. Once you've made it to that step, it's too late. But up until that point, custom allows us to navigate to different portions of the installation. So it gives us much more control over the installation process. They look similar on the surface, but the ability to navigate at will with custom makes it a little bit more flexible. So let's go ahead and do custom. Now I mentioned before that there's some options you can determine during installation. So for example, we see that IPv6 is set to off. This can be set to on by just using the spacebar to toggle it, for example. So let's go ahead and go back to the main menu with Q. Q is the option to quit from most of the menus, the submenus, to return us to the top level menu. So let's go ahead and just proceed here with custom and then set up our partitions. Now this time, because there are at least 2 disks, sysinstall will detect and display those disks. So let's go ahead with partition. There are the 2 disks. So where would we like to perform this operation? That is the configuration of the slices. So it mentions if you're attempting to install a boot partition on the drive other than the first, or you have multiple operating systems, you have the option to install a boot manager later, which makes sense. So we've pressed spacebar on DA0, and there is the original slice. Now notice that the slice is not set to be bootable. So let's go ahead and select the S option, and that sets it to be bootable. So that slice is in place, and then Q to quit. And this asks us above if we'd like to install a boot manager on DA0, so we'll indicate yes. Now insofar as the DA1 is concerned, we'd like to allocate a slice here as well. So let's go ahead and press spacebar. Notice above it reads disk name in the upper left hand corner, DA1. That tells us that we're within the context of the second disk, which is also approximately 8 gigs. So let's use the entire disk, which is option A. It need not be set to bootable as it's our secondary disk, and it will contain other mount points such as perhaps var and maybe swap. So we don't need to set it to active. Let's Q to finish, and we don't need to install a boot manager on DA1. So now we're set. We can proceed by pressing enter, and let's just go back in. That takes us to DA1, Q to finish, no boot manager. And we'll just navigate by tabbing down to OK. Now we need to label the disks. Labeling allows us to allocate mount points to the various partitions. So let's go ahead and label. And notice we have two disks that we can pick from, DA0, DA1. So beginning with DA0, let's delete the various partitions. So within the context of a disk, you can navigate down by pressing Enter and deleting the various partitions that are associated with it. And the order in which you proceed doesn't matter. So for example, if we select the DA1 first and then press Enter, then it shows us the context of DA1. So let's go ahead and delete the partitions. And now we've freed all the blocks. So to create partitions, let's use C and determine the blocks that are of interest. So how big should we make the root partition on DA0? Supposing a gig is sufficient, which will leave us 7 gigs for /user, which will be sufficient for the ports collection, will indicate 2 million blocks about. And again, if you divide by 512, you'll get a more accurate count. So this will be for /, which is simply root. And if you follow, that's on DA0, which is the first SATA or SCSI disk, slice 1, first partition. Remember, partitions are labeled A through H. Now let's create one for user. We'll use the remainder of the space, 14,771,797. That'll give us about 7 gigabytes. So the label editor allows us to make these changes. So that will be the configuration for the DA0 disk. Now, insofar as DA1 is concerned, we will have to make changes to it independently. Now, we can save the changes for this particular disk by using the Q option at this particular point. We go back into label, we see that the changes have been committed for DA0. To create a partition on or a mount point on DA1, simply select C to create, and you'll see the full range of blocks. So there we see the 16,771,7997. These apply to DA1, second disk or SATA or SCSI. So at this stage, how do we lay out the 8 gigs that are here? Well, we have user and root defined, and we've mentioned that partition B is reserved for swap. So if we define an A, let's say for var, then B could be for swap, and then perhaps the remaining partitions on D, E, and so on. So let's go ahead and define perhaps a 1 gig partition for var. That'll give us another 2 million blocks. This will be a normal file system for /var. Let's double check our size. And that created it properly. We had an extra 0. So that's /var. And we also would like to create swap on the secondary disk. So let's go ahead and create that as well. The swap we said should be 2 to 3 times random access memory, which is currently set to 512 megs. So we can make that a gig, which is about 2 million blocks. And this will be of type swap. Just like with Linux, swap partitions differ from standard file system partitions. So now we have var and swap. But how about home? So we have 2 gigs, 6 gigs remaining. Home should be perhaps 4 gigs, leaving us some space perhaps for opt and otherwise. So let's create another one. And this will be 4 gigs for home, or about 8 million blocks. So far we're using roughly 4 million blocks. Let's just double check that. So 4 gigs, that's 8 million plus 2, that's 12 million blocks roughly out of the roughly 17 million blocks. So we have about 5 million blocks, or 2.5 gigs. So if we'd like to make a provision, let's say for temp as a gig, that's quite possible as well. Let's create 2 million blocks for temp, since the original installer set that up. Let's just make sure that we have the right number of zeros here, and this will be for /temp. And we have an extra 0, so that's going to be file system /temp. and that should leave us with just a little bit of space, as you can see above, roughly 1353 megs. We did say we'd like to provision space for opt, so perhaps we'll allocate a gig. So let's create roughly a gig for / opt. So what does this give us? Root, user, var, swap, home, temp, and opt. Those are common mount points. The user is the most important because, again, the ports collection will be expanded there. By no means must you install the entire ports collection, but it comes in quite handy. And in particular, with storage being abundantly available nowadays and so cheaply available, you might as well install the full ports collection so you can take advantage of all that software. So we have the key partitions that we need. We'll quit to save the changes. Now, insofar as bootable, the partition section is the most important. As long as it's set to active for the first disk, DA0, then you're fine. And it always sends us through this cycle, this loop. For DA1, we'll tell it not to put a boot manager. So our labels are intact. Everything is in place. We can always go to the label manager to see what's to be laid out. DA0 has two partitions on the same slice. S1 means slice 1. Partitions A and D, with B and C being reserved. And partitions D, B, E, F, and G are allocated on the first slice of the second hard drive. So let's quit to save the changes, and now we need to specify the distributions. This is where we indicate all. So this tells us that it takes a lot of disk space. It's actually more than that. And we'll tell it yes, that we're interested, and we'll go down to OK. This will install all the packages, and the media will be CD/DVD. If FTP or otherwise, specify through an H. Notice the HTTP option reference is really an FTP server using an HTTP proxy, so really it's telling us that it's installable via FTP, but there are ways to work around it. CD/DVD, and at this stage we can commit, and this is just a matter of waiting for all of the files to be copied from the appropriate media, which is mounted as an ISO image to the virtual VMware instance that we're currently using. So again, just to recap, what we've done in this particular installation is to provision extra storage, 8 gigabytes of storage. So another 8 gig block, which appeared, insofar as this virtual instance is concerned, as a second hard drive, DA1. A second SATA/SCSI hard drive, labeled as DA1. DA0 is the first SATA/SCSI drive. And we've elected to provision root as well as user on the first disk, DA0. And the ancillary partitions or mount points for home, var, temp, and opt, and the swap file system, an appropriate swap file system of roughly twice random access memory on DA1. And that makes it much more apropos for our configuration. And again, this is all within the constraints of very limited storage. Nowadays, storage is extremely cheap. You can buy terabytes for nothing, so you'll make your partitions much bigger. However, there's still some limitations, so normally you'll want to ensure that your boot partition is not too large. You'll just check the documentation to see what the limitations may be depending on your platform. With x86 64 or AMD 64, many of those limitations have been eradicated. However, depending on your configuration, sometimes you may find yourself attempting to provision, let's say, newer hardware on older hardware for the sake of recovery, and may encounter roadblocks that are imposed by, let's say, former BIOSes that have restrictions. So for example, if a machine crashes, but the storage you know is good and you'd like to mount it physically on an older piece of hardware to recover the storage, you might find problems booting FreeBSD from older hardware using a newer partition layout, let's say on a newer drive. So those are some things to consider, but by and large, the limitations have been removed, so you can set your partitions up however you see fit. The key really when partitioning is to separate your partitions in a logical fashion. So it's always important to keep things separate so that in the event that a process or processes run away and write too much I/O, generate too much I/O to a particular disk, it doesn't overrun the main root file system. So it helps if you can separate out var, home, and user away from the primary root file system. On top of that, it helps if you can spread out the swap file system, because it is possible within FreeBSD, as is the case with Linux, to create swap out of plain old files that reside within a file system such as root. However, that too can also pose a problem in the event that you exhaust storage. So let's say you have a 1 gig root file system and you put a half a gig swap file on that particular root file system, and then the root file system grows ever smaller and causes the system to panic and causes you to not be able to boot the system. So the idea is to leave as much space available on the root file system as possible, to provision as much space as you can for /user, to provide ample space for /var, and similarly for /home. We've also provisioned temp, which is set up using the auto partition configuration. One other note on partitioning is that in order for FreeBSD to boot your system, you need to ensure that the disk that is to be bootable is flagged as active, and you do that within the configuration of the slices. You set the slice as the active slice. In other words, that is the partition that will be bootable insofar as FreeBSD is concerned. Otherwise, it will not boot it. Expect some other boot manager to handle the booting for you. And as mentioned, the 2 consoles that are available, F1 and F2, are available throughout the installation. Other distributions of other OSs such as Linux may make more consoles available, say through F3 or F4. With FreeBSD, it's F1, which is the main console, and F2, which echoes the activity that's being carried out on F1. So F1, or the primary console, which is this colorized screen, shows us a summary of what's transpiring in the background. In the background on F2, we see the actual files that are being copied and expanded onto your newly provisioned file system. And as we've seen already with the installations, once this particular section is over with, we can then reboot the system. However, it doesn't force us to. It gives us the option to perform post-installation configuration. As you can see, unlike with Linux, we were not forced to specify network-related information up front, which means post-provisioning of the operating system, we have to, if we intend to connect to the intranet and then the internet, we have to configure the network interface or interfaces that are available on the system. So that's one step that's important before we reboot the system. However, if you neglect to do that, you may always run sysinstall once you've booted the system. So you may boot your FreeBSD system and it has no networking stack. Simply execute sysinstall and it'll take us to, or take you to, the same colorized screen where you can then navigate to the post-installation configuration section to configure your network interface for IPv4, IPv6, and to point to the DNS and so on. You may also configure your networking options manually, but if you know the files beneath the etc hierarchy to manipulate, that'll also work. But sysinstall makes the initial setup at least much easier. Notice that the bulk of the files that are being copied here correspond to the ports, because as we've mentioned, they occupy under a full distribution gigabytes of storage, the whole user tree, that is. So this is what's taking the bulk of the time to install. And it's not that the files are big, it's that they're numerous that causes it to take so long. So let's see, visit General Configuration menu for any last options, and if you'd like you can. Let's see which console we're on. It actually kicked us back to the F1 console, and we can tell it no. So this is done, it's actually installed it, and we can exit to the main menu either by navigating to cancel or to exit at the top, and then you navigate, if you'd like, to the post-installation configuration. So in this area we can specify, for example, the time zone. Our CMOS clock is set to UTC, so we'll be an offset from UTC. We'll use page down to navigate towards this particular offset, Eastern time, which is currently EDT. Then also networking, we'll specify configuring our interface. You can use spacebar. Remember, with FreeBSD, the interfaces are labeled EM followed by a numerical, and these are Ethernet interfaces, a numerical identifier, as opposed to ETH in Linux or EN on Mac OS X. So we'll tell it not to go at DHCP because we have an IP address, and its name will be UnixCBT1, UnixCBT.internal. You need not specify the suffix here, but we do it because it automatically transposes it, sysinstall that is, to the domain field. And the system's smart enough to use the short name portion to label the system. So for example, at your bash prompt, or if you type hostname, etc. The gateway is the Cisco router. The name server is this box 101, which is a Debian box. And our IPv4 address is 7540. No options are necessary at this particular point. So this will bring EM0 up, so if there are any hosts on the wire, you'll be able to communicate with them. And IPv6 will be configured. If you can see in the background there, the FE80 address, that is our IPv6 address. And if you'd like to synchronize your NTP, for example, with a remote system, you can. You can specify from various regions of the world, or you can specify an IP address of something that's on your local area network. For example, our 101 box should be functioning as an NTP server, so NTP date will attempt to synchronize the clock against that. We want to run SSH, definitely, so we can connect to the box remotely, and then we'll worry about the other services later. This also tells us that later on, when the system's up and running, we can use sysinstall to configure some of the core services. Security related to the system, NFS, set the secure level. There's some options here that we'll look at later on in the security area. Startup options, HTML documents, etc. User management, we've defined a default user named Unix CBT indexed at 1001. So let's just redo that since this is a new installation. It didn't preserve the settings from the prior installation. We'll just call this user 1 with a default of that. Since bash is currently not compiled, we'll stick with the C shell. And then we'll exit to the main menu. If there are any other options that are of interest, this is the area to do it. Otherwise, let's just set the root password. We can then navigate back to the main menu and reboot the system into text mode. So far so good. This here is the documentation. You can tell it to install all of the documentation for all of the languages. And we should have that already. Let's go back, since we selected everything during our installation. But if you didn't, the option's there. Sysinstall isn't configured to know whether or not you have done it. It just presents you with the option. Again, doc takes us to the documents that you'll find at the root of the CD-ROM, such as errata, hardware, copyright, etc., readme, etc. So at this stage, we're done. We can reboot the system. We can exit the installation. But we need to ensure that our BIOS will not boot from the CD-ROM. So there are a number of ways in which you can do it. You can actually navigate into the BIOS, or since it's VMware, you simply tell VMware not to boot from the BIOS, not to boot from the CD-ROM, that is, so it changes the BIOS. So let's go ahead and reboot the system, and we'll be back up shortly. This is the boot menu. Then once it comes up, we'll log in and just confirm our IPv4 address, ensure that IPv6 is configured, and enumerate the partitions using df. There's the SSH key generation for the first time the system comes up, which is unique to the system. Now let's take a look. We'll do an if config, and we should see that EM0 is configured with an IPv4 address of 7540. It has INET 6 addresses for link local 6 to 4. Loopback address is configured 127.0.0.1. Loopback for INET 6 is configured as : 1. And for the link local as FE80, terminating with a 1. Now, insofar as the partitions are concerned, df-h should enumerate the following: DA0 through DA1. DF does not show swap partitions. So here's the root partition. Now, the key is to see what capacity all of these are at, not the devfs, which is dynamic, but everything else. Notice that the user mount point slash partition is at the highest capacity, 58%, leaving us ample space, perhaps for a second ports collection, or a good amount of a second ports collection. However, the other mount points such as home, op, temp are virtually empty. So ample space is provided there. And var is also in a similar condition. The root file system is also at low utilization. So this is a proper configuration. Now, this sort of setup is ideal even for massive production systems because, for example, these two disks, the two 8 gig disks, could be used to run the system, and then additional storage, let's say provisioned via SAN, could be used, let's say, for your databases or your key custom applications. So this is up and running. Let's send some packets, perhaps 2 packets to the default gateway just to be sure that it's out there, and perhaps 1 to our NTP server slash DHCP server. Let's see if it responds. It's actually not responding, so that means it's down. So we'll look into that. But nonetheless, let's try someone else on the wire, perhaps 23. No luck there. So in any event, we have some juice, some configuration, some signs of life, and we're up and running. What we don't have is a graphical environment. That's something we'll have to look into to get us into GUI mode where we began our studies. But the key is now we've configured a custom layout of FreeBSD. And again, once you're up, you have a number of consoles that are available. You can use Alt F1 through F8 or Control Alt F1 through F8 to access those terminals. F9 is reserved to access the 8th terminal, which is reserved for X. These are all individual consoles that can be used independently.